All right, this is quiz 8. The first question says use the standard relations, and then it lists a bunch of trigonometric values to fill in the following values for the inverse trigonometric functions. Okay, the first one we're going to do is sine inverse of 0. Okay, so what does that mean? That means we're looking for some value that when we plug it into sine, we get 0. So in other words, I'm looking for an x so that sine of x is 0. Now if I look at my values, I'm looking over here and I notice that sine of 0 is 0. So the x value that I was looking at is 0. Thus we know that sine inverse of 0 is 0. Okay, the same thing for sine inverse of 1. I'm looking for some x value that when I plug that into sine, I get 1. So sine of x is 1. If I look through here, I find that sine of pi over 2 is 1. So pi over 2 is my x value. So I then know that sine inverse of 1 is pi over 2. Okay, finally, sine inverse of negative the square root of 2 over 2. Okay, if I look through, I see that sine of pi over 4 is the square root of 2 over 2. Now, this requires a little bit of reasoning. I need to look at my unit circle. So if I know that the sine of pi over 4, so this distance, this y distance here, is the square root of 2 over 2, then I need to know what angle gives me negative square root of 2 over 2. So in other words, what angle gives me a negative square root of 2 over 2 for the y value? And that's just going to be negative pi over 4. If I go up pi over 4, I get this a positive sign. If I go down or negative pi over 4, I get a negative y value. So this is negative pi over 4. Okay, now cosine inverse of 1/2. I look through, I find that cosine of pi over 3 is 1/2. So I get pi over 3 as cosine inverse of 1/2. Now tan inverse of 1, that's saying they want tan of x is equal to 1. Or in other words, sine of x over cosine of x, so the same x values that we plug into sine over cosine has to be 1. So I'm looking for something where the sine of some value is equal to the cosine of that value. So I look through here and I notice that sine of pi over 4 is the square root of 2 over 2, and cosine of pi over 4 is the square root of 2 over 2. So if I have sine of pi over 4 over cosine of pi over 4, notice this is tangent of pi over 4. This is the square root of 2 over 2 over the square root of 2 over 2, which is 1. So that tells me that tan inverse of 1 is pi over 4. Okay, now finally tan inverse of 3. So I'm looking for something that when I have sine over cosine, I get the square root of 3 over 2. Okay, so, the square root of 3 over 1. Now, I know that sine of pi over 3 is the square root of 3 over 2, and cosine of pi over 3 is 1/2. Now notice when I put the square root of 3 over 2 over 1/2, I can also then invert and multiply. So this is times 2 over 1, so those 2's cancel, and I get the square root of 3 over 1. So I know my angle then is pi over 3. Okay. The second question says use the derivative formulas and then lists all of the derivatives of sine inverse, cosine inverse, and tan inverse to compute the following derivatives. The first one is the derivative of x sine inverse of x plus 1 minus x squared under the square root. Okay, so the first one here, this is a product of two functions of x. So I've got x times sine inverse of x. Okay, so I'm going to have to use the product rule. So let's start, we'll take the derivative of x and leave sine inverse of x untouched. The derivative of x is just 1. So I have sine inverse of x plus, now we leave x untouched and take the derivative of sine inverse of x. And so we get x times the derivative of sine inverse of x, which is 1 over the square root of 1 minus x squared. Okay, now this second piece, notice this is going to be a chain rule. We've got the composition of two functions. The first function is this square root, and the second function is 1 minus x squared. So to use the chain rule, I have to take the derivative of the outer function, which is just this power to the 1/2. So I could rewrite this as 1 minus x squared to the 1/2. So if I do that, I can pull this 1/2 out front, and then I have 1 minus x squared to the negative 1/2. Now I have to multiply by the chain rule by the derivative of what's inside, which is negative 2x. This constant goes away. I pull down the 2 and I get negative 2x to the 1. So times negative 2x. So now if I do some simplification, I'm going to get sine inverse of x plus x over the square root of 1 minus x squared. Plus, now this 1/2 and this 2 cancels. So I'm going to get actually a minus sign. Right, so this minus sign here on the negative 2 stays. So I have a minus, the 2's cancel, and I get x over, notice this minus 1/2 is going to be a square root in the bottom of 1 minus x squared. Now you'll see I have a positive x over the square root of 1 minus x squared minus x over the square root of 1 minus x squared. So those are going to just go away. And all this ends up just being sine inverse of x. Okay, the second one, I'm going to have to use the chain rule here. This is the composition of two functions. I've got tan inverse of e to the x. So to take the chain rule, I take the derivative of the outer function first and compose that with the inner function untouched. So I get the derivative of tan inverse is 1 over 1 plus x squared, but instead of x, I plug in my inner function, so e to the x squared, times the derivative of the inner function. Well, the derivative of e to the x is just e to the x, so I get e to the x over 1 plus, now e to the x squared, that's e to the 2x. And that's our answer.